Hi everyone, welcome back to our channel. Today we are going to validate this MATLAB verification of KVL. Okay, so here we need to develop this MATLAB simulation. So it's very simple. This is an closed loop 1, this is an closed loop 2. So here just I am running the simulation. Here you can see here KVL of loop 1 is verified as well as KVL of loop 2 is verified. So here I have been applied just only 20 volts. The drop across this 47 ohm is 1.3 and the remaining is 18. So 18 plus 1.3 and minus 20 is equal to 0. Entering voltage is 20, leaving voltage is also 20, therefore it is balanced. And the voltage at this point is 18 and 18 is observed as 9.3, 9.3. Okay, 9.3, 9.3 is 18.6, therefore KVL2 is also verified. Now we need to develop this circuit in the MATLAB. Okay, so that's why learning the MATLAB will give you a knowledge about like this. What happens to an inductor in DC supply is given. Okay, so DC supply is given, inductor will try to act like a short circuit and it gets fully charged. Okay, so like this is some beautiful concepts what you feel in tough in engineering you can understand well with simulation. Okay, now let's try to design this. Okay, so in order to design, first open the MATLAB window. Okay, when you open the MATLAB window, it will be open like this. At the top you have a MATLAB Simulink. Click on the MATLAB Simulink and click on the blank model. Okay, a blank window will be open. So keep this blank window to the right hand side and keep it in an enlarged size. Okay, so this is the enlarged size. Okay, and the original MATLAB you minimize, and this is what we need to develop. Let us try to keep it in an normal form or in first half. Okay, so this is what we need to develop. Okay, so in order to develop this, let us try to see here what are the elements actually we require. Okay, so here we require resistors, voltage source and voltmeters, that's all. Okay, so it's like an bridge T network, 1 2 3 4 5. Okay, 5 resistors you require and one voltage source. So where we have these elements is here at the top you have an library browser. Click on the library browser, a window will be opened like this, and at the scroll it down you have an simscape. Under the simscape you enter into subsystem of electrical. Under this electrical you go into specialized power system, go to fundamental blocks. So to do all the simulation you require an power GUI. Drag it and keep it in the untitled Simulink circuit diagram. Okay, and then you require voltage source. Double click on the voltage source and drag the voltage source, keep it in the untitled. Okay, so now you have DC supply and we require the resistance. Under this electrical sources you have elements. Click on the elements and drag the resistors and keep it in the location. Okay, so move it down and these are the elements. So double click on this series branch element. We require only resistance, therefore label this as only branch type is R. Click on apply as well as OK. So double click on it and first try to inject the elements, later we'll change the values. Okay, so resistor 1 and click on this block and use Ctrl C button and paste the here as Ctrl V. Okay, and again copy this value and paste it as Ctrl V, but we require in vertical value, so just use Ctrl R button, it will rotate. Okay, so copy this Ctrl C and paste here as Ctrl V, and I require one more element. Copy this element and paste this element as Ctrl V, and here I require an inductor. Double click this inductor and change the properties of the inductor branch type as inductor and click on apply. Okay, so now let's try to give the connection. Here we need to verify KVL, we require voltmeters. Okay, so after electric we have electrical sources, electrical elements, and we have measurement block. Okay, so here we require voltage measurement. Let's try to pull out the voltage measurement block and keep it here. Okay, across each element we require the voltage. So arrange the elements properly. See here, now I am arranging the elements in such a way that easily I can inject a voltmeter and all the blocks. Okay, keep this power GUI at the top of the diagram. So now let us try to connect it. So directly give the connection. So from this resistor to this, and from this resistor to this value, and here you have one more resistance. Add this resistor and add this resistor, and these two are in series, and these two are in again connected to neutral to form a closed path 1, and this is closed path 2, and we need to measure. Let's try to inject the values. Okay, so you can directly see in the diagram also, you can do it. The voltage source is 20. Double click on it and give the voltage as a 20 volts and click on apply. Okay, and this is 47 ohms. Double click on it and give it the value as a 47 ohms and click on apply as well as okay. And this is 2000 ohm resistor. Double click on it and enter the value as a 2000. So for this already theoretical calculations are performed. I will leave in the channel, you can watch from there. And this is a 500 ohm resistor. Double click on it and enter the value as a 500 ohm resistor. Click on apply as well as OK. So here you have one more resistor. This is also 500. So double click on it and enter the value as 500 ohm resistor. Click on apply and OK. And you have one more resistor which is 50 millihenry, and here it is millihenry, it is 1. You just enter it as a 50 millihenry and click on apply as well as OK. So now we need to check out all the values. To see the output, we require click on the library and go up and come to sinks. What I want to see is display. Drag the display and keep it in the untitled Simulink. Okay, so now here you can see here this is an voltmeter. Now let's try to give the connections to the voltmeter. So connect the voltmeter in parallel to the supply. Okay, and let's try to write down this voltmeter value. Just connect the Simulink. Okay, just click like this. So and here I require one more voltmeter. Copy this value. So copy this resistor value and keep it the voltmeter here. Copy the voltmeter and connect positive to positive and negative to negative. Okay, it is showing in red color. It's nothing but improper connection. Okay, so now it is a proper connection. Copy this value and paste here. Okay, just connect to display, and again copy this voltmeter and paste it here and connect positive to positive and negative to negative and connect this scope. Copy it and paste it as control B. Okay, and again copy this voltmeter and paste it here and connect positive to positive and negative to negative and keep the scope here and connect it directly to the output and copy the voltmeter, paste it here, connect it to positive and connect to the negative, and similarly copy this voltmeter, connect it to positive and connect the another terminal to negative, and you want to see the output, copy it, paste it, copy it, paste it, and directly keep it in the straight, it will get aligned. So we already defined the sources. Let's try to run whether it is giving the values or not. Okay, so this is saying that unmeasurement voltage went block. Okay, somewhere voltage is not mismatched. So like this, if it is giving in red color, you have to give it as a black color where it is perfectly connected. So now we will not get any errors. So now you can see here I applied 20 volts, the voltage across this resistor. If you want to write this value, at the bottom you have series RLC, there you can click it and you can write down the value as 47 ohm resistor. Okay, and here also you can click and you can write down this value is 2000 ohm resistor, and next value you have this value is 50 ohm resistor. This is 50 ohm resistor, and this value here we have, this is also 500 ohm resistor, ohm resistor. This is also 500 ohm resistor, and this is 50 millihenry inductor. Okay, so the rating of this inductor is 50 millihenry. Okay, so now you can see here we need to verify the KVL. Okay, so how to verify the KVL is here you can see here, actually it is verified. So in order to make you understand, I will show the proof also. Okay, so 20 volts I applied, the drop across this resistor is 1.317 volts, and remaining is 18.6. So 20 is equal to 1.317 plus 18.6 is equal to 20. KVL is balanced. Okay. So coming to this loop, so from in 820, 1.3 volts is dropped, remaining is how much? 18. In this 18, 9.3 is the drop across this resistor, 9.3 is the drop across this resistor, and this inductor is acting like a short circuit. If it's acting like a short circuit, the meaning is it acting like a short circuit and gets fully charged. Since it is short circuit, voltage is 0. So how to prove is, I want to add all these things. So for this, you can go to Simulink library and you can select math operations. From math operation, take an adder. Okay. So here we have to add all these things value. So double click it and let's try to keep the signs as negative. Why? Because one is entering, remaining are leaving. Entering is positive, leavings are negative. Let's try to define here. Okay. Let's try to connect the scope and paste it here and write down this is KVL for loop 1. Okay, so you can see here the voltage at this point. Let's try to connect to 20. Okay, and connect this to the another voltmeter, which is nothing but 1.7, and another also you connect to here. Okay, so when you run it, enter is 20 minus 1.3 minus 1.6, therefore automatically it is equal to 0. So the KVL of the first loop is completed. And now let's try to copy the same summer and place it here as control V. And here you can see here the original diagram what we already designed. Okay, so here uh, all are entering this here, leaving, therefore you are going to get negative, and already we verified this. Okay, so this already we had run. Let's try to do the same here also. So here we have 1 2 3 4. Okay, double click on it and all these are negative, keep it, and one more negative, just click on apply and okay. Okay, so for the just drag the adder and connect the positive to positive. Next one, this is leaving, that's why negative. This is also leaving, that's why negative. This is also leaving, that's why negative. Okay, so now let's try to connect the output. Copy this output and connect it to the output. So now we are going to verify the KVL for the loop 2. Just run the simulation. So now we can see here entering is 18.6, leaving is 9.3 minus 9.3, which is nothing but 18, plus 18 minus 18 will get cancelled out, and the voltage is 0, and inductor is short circuited and it can store the voltage. Okay, so this is what's happening. Therefore I can say that KVL for loop 2 is verified. If you want to put the name, you can very simple, here you can just type MATLAB verification of KVL. That's all. Okay. So just click add MATLAB to annotation. Just select all and keep the bold and keep the size as 24. You'll get it. Okay. And if you want colors, go for colors. Keep it on red. Okay. So this is how you are going to get the MATLAB verification. Okay. So MATLAB verification of KVL. So you can see in detail by making it zoom also. So hope you are able to understand the content. Okay. So 20 volts I applied, 1.3 is the drop, 18.6 is the drop. Source voltage is equal to load voltage. This is the load absorbed by this 47 ohms resistor. This is the voltage absorbed by 2000 ohm resistor. And here in this 18, 9.3 is absorbed by this resistor, 9.3 is absorbed by this resistor, and nothing is absorbed by, because 9.3 is already balanced. Okay, so this is the verification of KVL. Okay, so like this we had made an almost all many videos having a standard procedure. Is first procedure we had done the theoretical calculation for this verification of KVL, and second we had made an hardware. It's nothing but hardware setup for this is the second step. Third step is MATLAB simulation based verification. Okay, so that's why we designed this MATLAB simulation type. So all this, if you do a problem analyzing the theoretical hardware and MATLAB, you'll become expert in circuits. You can do all the magic what you require to acquire knowledge in circuits. Hope you're able to understand. If you feel my content and explanation is good, please give a like to my video and share with your friends. And if you have any doubts, let me know in comment section. I will answer your comment. And if you are watching my channel for the first time, subscribe to my channel with the name KV Tulasiram. Okay, so kindly support this sort of free channels for the development of students as well as for development of faculty. Thank you for watching. We'll meet with another good video in another